Hey everyone, hope you are enjoying our previous classes. So today we are going to learn about BIAS, that is Variational Autoencoder, its training process, its applications, and also we'll learn about transformer model, its training and its uses. So stay connected and enjoy the session.
In 3D image creation, there is a product called 3D Model Creator. You create the 3D models like your MATLAB, they create the 3D mathematical models. Okay. Then finally, your Juke is one of the example of open AI where it uses the audio and music generation concept. All these illustration of versatility and transformative potential gains in various industries. Now, driving innovation and enabling the creation of new products. Now, the point is, it is versatility and new products. Both the things it can generate. But still, it has some demerits. What is the demerits? The training set should be very high. If the training set is less, it will be not stable. So, the new concept of VAE introduced into the market. Right? Even if the training set is less, even if you have a very bad picture and it, it is not a high quality picture to understand the differentiation, still this model, which is called variational autoencoders, they can create a good picture out of that. And it it use the distribution logic and sampling data together to decode and produce the output. So here, as you see, the example is the encoder. They give a input of Mona Lisa, which is very bad in shape. Still, they understand all this logic, they encoding and decoding. So um, with the development of the digital world, all the pictures can be divided into pixels. So each pixel can be encoded and check whether the quality is correct or wrong. And each pixel again will be decoded with a high quality. And when you combine everything, you'll find a output. So you can see the structure is very simple. There will be two parts, an encoder, decoder architecture, where the encoder maps input data to the latent space. This is your latent space, and decoder maps it back to the data. Okay. So what is the function? Here you learn probabilistic mapping. Now, what is the probabilistic mapping? So when they create the distribution of this picture, they understand, okay, this is picture, this is the color, and all these probabilistic, they add on. So if some pixel is missing, they understand this pixel should be similar to that color because the string is there. So from the distribution logic, they understand what should be the fixing point, and they improve through that by decoding that, right? So that this model is again has its own structure. It's have three segments actually encoder, which captures the data. If we consider there is an example of encoding data XXX to a latent space of ZZZ, producing two outputs like a mu and divided by mu, and the variation is your psi sigma of the latent variable distribution. In this case, you can see there are two stuff. One is input data, where is triple X is there, and other one is your space, where is triple Z is there. So your function has your equations. Now these equations need to be divided. So what it happened in the distribution logic, it divided the Z into QZX, QZX, QZX. So it divided into three segments. So each segment is divided into three segments. Then it applied the Gaussian distribution law. Probably you all have mathematics right now, or BTech. You can understand the Gaussian distribution law, where it creates a picture and distributes everything through that diagram. So there will be a very bale size diagram will create it, and based on that, it understands which part need to be improved. So the distribution will be unique in nature, or it will be balanced in nature. So that part is encoding. What happened in the latent space? Latent space, it compressed everything and put into a lower dimensional representation. Like if there is a picture of 3D picture, it tried to put into a single dimension. Why to put into a single dimension? To apply the mathematical law. Okay. Then sampling and put everything in a sample data format and check and improve that. So your sample data, which is distributed into QZ, QZ, and QZ. So apply those information and draw a distribution diagram. Then finally decoding. To balance out that diagram, Gaussian distribution diagram, you have to decode it and put the exact space, aiming the restructure and re-originate the picture into a very high quality input. Okay. Output the decoder output to probability distribution. Now, after using the Gaussian distribution, you use the probabilistic distribution to check which probably will be the best one. If your probability will be best one, the output will be the best. Now, let's consider your output is not so good. What you will do? That same output will be again given into the system and it will train itself till you are getting your uh, objective. Okay. So you can see there are two parts again linked to the output. Reconstruction loss and KL divergence loss. These logics are used. That means if I'll say in a layman word, we'll keep trying to get the best diagram out of the picture. So we apply the Gaussian law, we apply the probabilistic law, and finally we train the system to restructure and remove all these noises and reconstruct the losses. And through that, we'll get this. Now, these VAE are very powerful, versatile tools to realm of generative models. Now, this model is used in most of these cases. It provides a robust probabilistic framework for learning and generating complex data distributions, making them applicable in wide range of fields from image processing to healthcare. Despite some challenges, their ability to create the meaningful and continuous latent representations make them a valuable asset in the toolkit of modern machine learning. Okay, so now machine learning has just two equations, whereas generative AI put this latency in between. So that means whatever there in machine learning, it keep trying to improve that, keep trying to improve that. So that's how the continuous latent space is become smooth. Okay. Through this interpolation between the data points. So each time when it improves, the data quality improves. So now regularized representation, which comes from the KL divergence, to encourage the latent variable from known distribution improvement to robustness. Robustness means whatever you are expecting, you are getting actually. All right. So all these stuff is linked to your probabilistic generation because at the end, the probabilistic framework is giving you the new data points, which is useful for various applications. Okay. Now, what are the application of VAU? Obviously, in image generation and reconstruction, data arguments, anomaly detection. Now, anomaly detection, like somebody is trying to break your password. Okay. Is giving some identity which is not correct. Okay. So the system can understand that by encoding, decoding, encoding, decoding. And each time when it is encoding, it will be more uh, nearer to understand what is it is a fake or it's a real. Now, representation of learning, text generation, and drug discovery, very similar to your GAN model. So what are the limitations? Why this model still has some limitation? Now the limitation is if the input image bloodiness is very high, it cannot reconstruct it. Okay. If the complexity in the training set is also very high, it cannot balance and restructure a good picture. Okay, and finally, there is a concept called mode collapse. Now, similar to GAN's, we can also suffer from a mode collapse where model generates a limited variety of output. Okay, so let's consider, I'll give one example. Somebody capture a picture of a thief from the CCTV camera, and that CCTV camera capture the picture is very blurry in nature. It's not clean. Okay. And that person who is the thief, he put some kind of police dress. Okay. Okay. And when we give that to this model, VAE model, it expected the training set, and all the sample training set are given from the same police station. Because of the blurriness, it tried to do encoding, decoding, and it creates a output who is the inspector of that police station. Now, that's not correct. Okay. But it happened because it has very limited number of samples. It is not able to clear if the picture is very blurry and the training set is very complex. Okay. How it's complex? Because the system always expect that the like it's a human being always expect like if somebody is into khaki dress, he should be a police officer. Uh, like if he put a police dress, he should be a police officer. So the system get biased and capture the picture of a police person who is in the training set. Now that part the mode collapse is you have limited number of inputs or training set. From there, it captures something which is very similar to that. Based on the blurriness and complex image, it cannot understand which one is correct. Now, that's obviously a very dangerous stuff. So we move to another stuff, which is we'll discuss again, that is called diffusion. And so that we can resolve this issue. Now, what are the products developed through this? Enhancement of MRI or CT scans, synthetic model data generation, drug discovery, chemical property prediction, all these things can be done. Why? Because all these things has at least some base data, which is good images or good quality scanning data. So through that, the output can be generated. Okay. It also involves into image and video processing. Like if there are some noise in your image or there are noise in your video, it can resolve that super resolution. So there are products which are do this stuff, very popular products. And anomaly detection in images. If your image, if something is unusual, okay, it can understand. And if you try to compare between two images, okay, like in some offices, there is a concept called image detection attendance system. So when you go, there is a camera. You have to stand in front of the camera will scan you, then it will open the door. So those kind of stuff is used by VAE technology. Even if in natural language processing also it is useful because it do all the sentiment analysis, emotional detection very well. So if you are happy, you are laughing, it can detect. If you are sad, it can detect. So those sentiment analysis part also done very well by this model. Um, Behavior analysis also it do well, like based on your sitting position, based on your communication, it can understand your personality. Data argument, synthetic data generation, training AI models, that also it do well. So all this stuff is good. Now, privacy preservation and data generation, it is mentioned here, but there is a lot of doubts on that because sometimes it creates the uh, data which is actually hampering the privacy. Okay, now that's a big debate these days. But yes, it also help you to preserve the data. Mostly in banking segment, they use this to understand whether the person who is calling is a correct person or not. So all this stuff is there. And creative industry, obviously, it clear the picture, clear the music. As auto tunes are very good examples of these VAE models. Even if the person is not having a very natural voice, they can auto tune to a voice which is very sweet and uh, audible. So those things are there. Content creation tools also are useful, particularly in text and other stuff. Gaming, virtual realities, example of a specific products like, again, NVIDIA's Bogan is one of the example. OpenAI, Dell E, Google Deep Dream, all these are examples of VAE. You can go through all these products and check how they behave. Okay. Now next model which come into picture, as I mentioned, the mode collapse is one of the major issue in both the models in VAE and in GAN. So you know what, you understand what is mode collapse, right? So it, based on the training set, it will generate very limited outputs. Okay, no, that is called mode collapse. So even if you can play any social platform game, if you like, I was playing one game called What Would Be Your Profession? Okay. So what I'm trying to give, I give my picture. Now, based on my picture, it will predict what should be my profession. And it will generate a picture with like military person or with a doctor like that. So when I use that first time, it produce a military person. When second time, it produce a doctor. In third time, it produce a engineer, or in fourth time, it will produce a firefighter. Again, fifth time, it again produce a military person. So what it means, it has very limited generative ability. Okay. So after 4, 5 stages, it get collapsed. So we call that mode collapse. So those problems are major in last two models. So we come into a model called transformer model. It uses simple attention mechanism to weight the importance of the different elements in the input data. Now, transformer model is mostly useful for NLP parts, for language and text generation, and it used multiple layers to understand your data. It divided the whole input into small chunks, and those chunks or text it understand, and based on that it search what should be the output. So the major concept used here is tokenization. So it is again two parts in transformer model, encoding and decoding. In encoding, it has multiple layers. Each time it move the data, it will transfer the data into small chunks and try to understand more, and more. Finally, once it understood, it will give you the output, and that output again go through multiple segments to understand whether the data is correct or not. Now, we'll have a total session on tokenization because that is one of the major part of NLP and your Gen AI. Apart from that tokenization, it also do one major stuff. It always compare between encoder and decoder data, okay, to give you the unique data. Now, what is the objective of this? What is the core concept of this? This core concept, or the layers, are three major layers in this. The first one is your self-attention mechanism, because as in last segments, we understand the can mode collapses happen, but here the mode collapse will not happen because it divided the whole segment into different uh, chunks. So if you give some text message, mostly it used for text one, LLMs, large language models, where each word they can divide into tokens in input sequence and transform into vectors. So what are those three vectors? It will divide into query, key, and values. So even if you give a word or a token, it divides into three vectors. So each time it transforms into queries, keys, and values. Let's take one example of hi, how are you? Now, how are you doing? So, what is the sentence? Hi, how are you doing? Now, it again divided into hi into a particular segment and check whether it's a query, key, or value. Now, what is that? If it is a query, it should come with, like, based on the language processes, it should be with a WH word, like how is a WH word. So HOW. So it understands it's a query. Or is it a key or a query, or is a key just to enhance the combination? Okay, U is just a simple vector, or you can say a value. Okay, doing is another, it divided into same, and with the question mark, it understand it is a query, right? So, hi, how are you doing? Question mark. So based on that, if there is a question mark, it will give the output. Okay. Now, this encoding and decoding happen and they divided into query, key, and values. And based on these values, it will create a score for each word here. Calculate the using the dot product of their query. What is the dot product? So, okay, I'll explain in details in some day, but for the timing, let's consider you have a dictionary. So let's consider a boy, and that's one word. Now somebody say baby boy, somebody say a small baby boy, somebody say beautiful small baby boy. Now each time when it understand, it is dividing that. So those kind of dot values, it will understand and divide them. Queries, key vectors, followed by these softmax operations and obtain the weight. So which one is the weight? Small is a weight, baby boy is a weight, because baby, we understand their age, it should be within 3 years, because afterward they will be kid. Boy is a weight, because we understand their gender, and other two stuffs are just connections. Okay. Beautiful small baby boy. Now, beautiful is a relative term. It may be somebody, for somebody, it may be beautiful, somebody, it may be ugly. That's a relative term. Small, again, another relative term. Okay. So these weights are then used to compute the weight of some of the values or vectors, and then resulting the self-attention output. So what exactly they are looking, we can understand from there. Then multi-head attention is happening. Now each head, each token, each head, they understand what is the thread, from where they are coming, from where they are going. There is a question mark, like in our example, it's a query. So they are looking for some answer. So each head independently analyzed and prepare the result. Then positional encoding is happen, and the purpose, since transformer do not inherit the capture the order or tokens, we push this to RNN. It's again a part of neural network, and position encoding added into the embedding the provide information obtained from the positions. Now, the positions are important because based on the position, the values get changed. The tokens sequence, based on the sequence of the token, the values get changed. So yeah, that's like in English grammar, it is very common there. Based on the positions, the meaning is changed. Now, based on those positions, we understand the typical value. And when we understand that, we derive the output and give it. So first, we understand the self-attention mechanism. We divide everything into tokens. Each token we divide into vectors, query, key, and values. Now, each of them will be passed to thread. And from the thread mechanism, we understand what would be the next head, and from that we'll proceed to each of their basic root of the head and concentrate on the linear transformer to produce the output. Then based on their sequencing and positioning, we understand what is the value of that, and we pass them to a neural network to get the output from these tokens which are given as input. So that is how these three segments are worked. And it worked into two parts. So the architecture is of three segments, whereas it has two segments, encoding and decoding. Encoding take the inputs and divide it into like small vectors, as we say, a key value and a query. And then it will pass on, and the decoder understands the sequence and the multiple values and prepare the output based on the input as the token. So that is the simple architecture. Now, to train each kind of data set, we need huge amount of text data. Okay. So because it's a supervised learning, probably last time when we were discussing the ML machine learning, we understand there are four types of learning: supervised learning, unsupervised learning, reinforcement learning, and there is a semi-supervised learning. So basically, everything is called supervised learning, unsupervised learning. And once you learn something from the current input, and again you reinforce that to correct your model, that is called reinforcement learning. But sometimes it happens that whereas supervised learning need huge amount data, unsupervised learning need very complex algorithms, we merge them together and create a in between a model called semi-supervised learning. Okay, so now in this case, in this model of transformation, we use the supervised learning. A huge amount of data sets are there and algorithms are propagating to find the exact output. To maximize the difference between the predicted output and the actual target sequence, often using the cross entropy loss for the classification task. Now, cross entropy means if there are huge data in both the segments, so it happens that the output will be lost and some very basic summaries are coming out of that. Okay, that happened. But that is what is the objective of any of the LLM. Okay. So what is the applications of this model is text generation, machine translation, text summarization, question and answering, sentiment analysis. All these text related stuff is related to your transformation. Okay. Next, what are the advantages and limitations? I'll not go into that in deep because, um, during the text communication, you have to give the input very properly. That is called prompt engineering. If your prompt engineering is not correct, so it will be very slow to give you the data. Okay, so prompt means how you are asking the question to this model. Okay, if your questions are very well and it is trained well, it will give you the answer exam set. It's give you the answer quickly. Long range depends because it is using a huge amount of the data set. So what is the limitation? Computational intensive. If you put something very complex in nature, as because of the large model, it will take a lot many time to extract the correct information. Data hungry, they need always large amount of training data perform well, which can be constrained. Okay, when there is a large data set, large data centers, or large databases, which need lot much maintenance money. So transformer models represents a significant advancement in deep learning, particularly for NLP. And their architecture based on the self-attention has set new benchmarks in various tasks, enabling the development of highly capable AI systems. Now, the good part of this for the engineering student is that it generates the codes as well. So you need not to learn any programming language or something. You can ask this model, can you generate a code for me? It will give to you. So what are the products or notable transformation models? The BERT, PERT is bidirectional encoding representation of transformers are very popular because it fine-tune any NLP task and give you the answers. GPT. GPTs are very popular these days. Chat GPT, GPT-4, all are related to this model. T5, text-to-text transformer model, transformer XL, all these are related to this transformer model. So in your Next task. The task is you have to log in into the chat GPT. Everybody has ID in chat GPT. Very good. So once you are using the chat GPT, okay, I believe everybody have the access. So then we'll proceed to another model called that uh, the diffusional model. Okay, so I'm just trying to open my chat GPT. So use your chat GPT to ask what is AI and how they are answering. Now, this is one of the transformer model. It capture all these information across what are the text and library it has, and it is answering you with a very clarity. So when you are asking something, like, it is also learning. But if I ask something which is not known by it, what is my name? So it is saying that I don't have access to your personal information. But can you tell my name? Yes. I'll say my name is, and then now I'll ask, what is my name? So like this, I trained the model. Okay, I gave some tasks, I give some input to this model, and then it is able to answer. So this is how the GPT models are using. And one of these application of the transformer model is your GPT.
So hope you enjoyed our today's session. If you like our videos, then do like, share and subscribe our channel.